Hello, class. Well, today we're going to be talking about slope-intercept problems in context. And, of course, when you see that word context, you know what that means. Word problems! Woo! Yeah, we love our word problems. That's real life. Not really, but it's as close as we can get to school without, putting anyone in danger. So, there are times when you'll have to write equations in slope, intercept, form given a word problem, word up. Okay, here are some hints on how to do this and do it successfully. So, first, you want to identify the slope by looking for how much something is changing. Keywords could include per, look at that cat sound, per, and each and for every. Okay, so if you see things like per mile or per dollar or per whatever or each or for every, any one of those could help identify your slope. Okay, remember that's going to be your m in y equals mx plus b. Okay, so the next step is going to be identify the y-intercept or the initial condition by looking for a starting point or a flat fee. This would be something that is the same regardless of the quantity of items being used, purchased, etc. Okay, and of course this is going to be our beginning or our b. Okay, so you're looking for your m and your b in y equals mx plus b. So really you're going to have the answer to all of these start off with something like this: y equals blank x plus blank. And if this turns into a negative quantity, you're just going to turn that to a subtraction. That's all. Okay? Real simple. Let's take a look at a few examples. Okay, London is driving to a concert and needs to pay for parking. There is an automatic fee of $10 just to enter the parking lot. And when she leaves the lot, she'll have to pay an additional $2 for every hour she had her car in the lot. How much total money would London have to pay for parking if she left her car in the lot for 5 hours? How much would London have to pay if she left her car in the lot for T hours? Well, again, we're looking for something pretty straightforward. Because they want us to use T this case, this is taken directly from delta math. It's going to be y equals mt plus b, okay, because they're looking for a t instead of an x, okay? So that's how much something's changing, and this. So if we go y equals, how much is it changing each time? What's our per? Let's see. Here we go. $2 for every hour. So our slope here is going to be 2t. And then the flat rate, the thing that doesn't change regardless of how many hours she's in there, it's $10 just to enter. Okay, 2t plus 10. So that's actually the answer to the second part. How much would she have to pay if she left her car in the lot for t hours? It'd be 2t plus 10. Okay. In terms of how much would it be for 5 hours? Well, that would simply be y equals 2 times 5 plus 10. 2 times 5 is 10 plus 10. That would be $20 for 5 hours. Okay. Again, this is pretty straightforward stuff. Got to pick out some very pertinent information from the problem and plug it right in. Pretty straightforward. You should be able to get this. Let's take a look at another one. Claire is going to an amusement park. The price of admission into the park is $30, and when she's inside the park, she'll have to pay $4 for every ride she rides on. Those better be some pretty darn good rides. Just saying. That's pretty expensive. Okay, anyway, how much would Claire have to pay in total if she goes on 9 rides? How much would she have to pay if she goes on all rides? So in this case, our equation looks like this. Y equals m. They want us to use r here. So we're going to go r plus b. Hey, Mr. plus b. Anyway, admission fit park, $30. That's a flat rate. That's going to be your initial condition. Okay, that's your beginning. This $4, boom, that's going to be right here. That's your slope. So y equals 4 times the number of rides plus the $30 initial fee. Okay, so here we go. Let's take a look at it here. Y, so if she rides on 9 rides, it's going to go ahead and put in 9 for R. So we have y equals 4 times 9 plus 30. Okay, 4 times 9, 36, plus 30. That's going to give you $66. Expensive day at the amusement park for only 9 rides. Though I'll tell you what, a lot of times they'll whack you for that $30 just for parking, so I don't know about that. Okay, write a linear equation, slope intercept form to model a situation where x, okay, good, we have x, is the number of minutes and y is the total charge. A telephone company charges $28.75 a month plus 10 cents per minute. I love it. Okay, so we know that y equals mx plus b. Okay, flat fee right here, $28.75. That's your b. This 0.1 is our slope. So y equals, make sure you put this in 0.10x. Don't put this down as 10x, okay, because that'd be incorrect. Plus 28.75. There it is. That's your equation right there. That models the situation. Okay. Let's take a look at another couple examples. Last couple here. So, write a linear equation in slope-intercept form to model a situation where x is the number of toppings and y is the total cost. Well, here we go. One of my favorite, the pizza problem. Okay, so again, we have y equals mx plus b. Okay. A pizza place charges $12 for a plain pizza and $1.75 for each topping. Well, you're only going to buy the plain pizza one time, so that's our beginning. Before we put any toppings on it, we got to pay for that. And then our slope is going to be how much each topping costs. So y equals $1.75x plus 12. And last example here. Write a linear equation in slope-intercept form to model a situation where x is the number of minutes and y is the total number of gallons of water in a pool. Okay, so a pool with 690 gallons of water is being drained at a rate of 4 gallons per minute. Okay, well, here we go. Y equals mx plus b. Okay, our beginning is right here. That's where we're beginning. And drained at a rate of, okay, there's a rate. Okay, that's a good thing. 4 gallons per minute. There's our per right here. Okay, so because it's draining, I'm going to say that's a -4. So our equation is going to be y equals -4x plus 690. Okay, there you go. Pretty straightforward. Make sure you're finding your slope. That's how much something is changing, what's happening each time you change something. And then you want to find your y-intercept. That's going to be your beginning, your beginning every time for these problems. Okay, if you have any questions, go ahead and see me in class. Thank you.